Hello everybody, and thanks for joining our webinar on the Libelium Simfony Smart Parking Kit. In our session today, we will go over the software component of the kit. One key thing to understand about Simfony's platform is that the horizontally layered architecture provides all the necessary tools to design, build, and operate IoT projects. The platform features are not aimed at a specific vertical or industry, but rather provide generic features that can be combined in various ways for rapidly rolling out any IoT project. The Smart Parking Kit allows anybody not only to test a solution, but also tailor it to specific needs and effectively move from the drawing board to a live deployment. The kit comes along with all resources pre-provisioned, all 10 LoRaWAN-based parking sensors, plus the LoRa gateway connected with Simfony's global mobile connectivity service. This allows you to use the kit anywhere in the world. The Manage Devices tab allows us to provide each device with individual attributes or properties, and in the context of the Smart Parking service, the location is probably most relevant. Each device has a set of properties, which we call metadata, that will be used to hold this information. Let's configure these ones with GPS coordinates around the Libelium office. We can usually use Google Maps to get the coordinates, although in a real deployment, other methods can be used. We'll define two attributes for each device, holding the latitude and the longitude, and these will be later used, as you will see. Both the name and the value of the attributes are up to the user, and to save time, we'll only show the configuration of one sensor. Now that we have the details for each sensor configured, let's have a look at the default business logic that comes pre-configured with the kit. The application engine is based on Node-RED, which provides many benefits, most notably flexibility and speed of deployment. The default application logic is meant to receive frames from the smart parking sensors via the LoRa network, decode them, and then store them in a database. Each frame type is decoded individually and the appropriate action is taken. The frames that carry information about the status of the sensors are used to update this into the database, while control and configuration frames will trigger back the appropriate responses. The application comes along with a logic for calculating both parking session duration and costs. This information can be used for both statistical and monetization purposes. That is actually all you need to get things going. Now let's have a look at the simulated data and what can we do with it. All data saved by the application layer into the MongoDB collection is available into the reporting engine. This can be used to create custom reports based on the data and structure of the saved documents. We'll use the collection storing the live status of the sensors to create some meaningful reports. You can see here data fields available to the reporting engine, and we can select the wanted one to create several types of reports. Let's start with a table report that contains the name of the sensors, their status, the time and type of the last received message. We can save this report to make it available directly from a dashboard at a later time. Let's give it a name and assign it to a dashboard. We'll create a new one for this purpose. The reporting engine has several types of reports available, each with various grouping and selection options. Let's try another report, this time a pie chart showing the number of occupied versus free parking sensors. We'll use the status field as a grouping criteria and count as the report information. Oops, my bad, let me fix that. Now you can see the count for each status. The reporting engine lets you customize the look and feel, so let's give the fields a more friendly name as well as a more meaningful color. As you can see, this is quite flexible. Once we give it the wanted look, we can save it by giving a name and assigning it to a dashboard. We will use the same one as before. Next, let's have a look at how our dashboard looks. Both our reports are here, so far so good. Probably the most useful report for the smart parking application is the map report, so we will build one. We select the appropriate type and provide the engine with the fields that hold the GPS coordinates for each sensor. We then select the info that we want to show on the map, and that is it. You can now see the data on a map. This is simulated data, so not many differences, but you can see that one of the sensors has a different state. This will get updated as the information is coming from the sensors. Now let's see what we can do with the cost and duration information. We can use the table format to get details about each parking session, the start time, end time, and the cost. Actually, let's add the duration as well. These are automatically calculated by the application logic and saved into a database. This one is expressed and rounded to minutes, but other options can be implemented. Another useful report is the sum of all parking sessions, revealing the total revenue on a specific time frame. You can select today, last week, last month, a specific interval, or none, which will make a sum based on all available records. I will put this into a more friendly format and add it to our dashboard. Let's have another look at our dashboard. You can see the details for each sensor on the map report, and this gets updated in real time whenever a frame from the sensor is received. The reports can be embedded in external websites or accessed directly via an URL, after this option has been enabled per report. For table report, there is also the possibility of downloading a CSV with the corresponding data if you want to use that with other applications or external services. The cost calculation can be individualized per sensor, for example, by using the metadata we've also used to store the GPS coordinates. This can be useful if you want to install the sensors in a different area of a city with different parking tariffs or even in different cities. The stored data is also available programmatically for those of you that want to use it with other external services. Each collection has all the needed details that are required to connect directly to the database. Data can also be pushed from the application layer whenever is needed. The main dashboard can be used to rapidly view existing reports, so let's add some of our newly created ones here. As said initially, the features presented in this session are just the ones that come by default, and the server logic is totally customizable to fit other requirements. We are looking forward to hear from you and find out more about your project, so don't hesitate to reach out. Thanks for watching.